Hello, everyone. I wanted to make another video for you to help with condensing logarithms. There's another video for expanding logarithms using the product, quotient, and power rules to go from a big scary expression inside a single logarithm to expanding that out into a sum or difference of separate logarithms. Again, the product rule says if you have multiplication inside, that turns into addition outside. Quotient rule says if you have division inside, that turns into subtraction outside. And the power rule says if you have a power inside, you can take that power, drop it out front, and that power gets multiplied by the logarithm. And then the big thing that I want you to kind of remember and grab from our previous video is that anything that came from the top has to have a positive logarithm in the end. So here in number 6, x to the 7th and y are both on top here. Notice the logarithm that contains x and the logarithm that contains y here at the end are both positive. And this z came from the bottom. The logarithm that contains z at the end here is negative. And then here in number 8, notice y to the 4th was the thing that came from the top. The logarithm here that contains y is positive. And the things that came from the bottom, the x to the 3rd and the square root of z, those things on the bottom, the logarithm that contains x and the log that contains z are both negative. That's exactly what should happen. Anything from the top needs to have a positive logarithm. Anything that came from the bottom needs to have a negative logarithm. So we are going to use those ideas and we are going to work backwards. What if we start with a sum or difference of separate logarithms and we need to condense those down into a single logarithm with a more complicated thing on the inside? Okay, so we're working backwards. So before we said that the order that we needed to do things in was the first thing that we were going to do were the product and quotient rules, and the last thing was the power rule. When we're condensing, we're going to do that in the opposite order. The first thing that we're going to do is the power rule, and then the second thing that we're going to do are the product and quotient rules. So we are going to do the power rule first, which means any exponents that are, or sorry, any coefficients that are out in front of a logarithm, we can actually put those up into the exponent. Just like here, if we took, like up here in number 8, if we took this exponent of 4 and dropped it out front to be down here, we can also, if we're working backwards, we'll go the other way and we'll take this 4 from out front and put it up here as an exponent. We're just working backwards. Okay, so let's start with number 1. First thing that we're going to do here is do the power rule. We're going to take any numbers out front. We have one in both of these, and we're going to work backwards. We're going to take these and put them up into the exponents. And so this is going to turn into log base b of x to the 5th power plus log base b of y to the 6th power. Those numbers out front get tossed up into exponents. Okay, so now we don't have any numbers out front, so we've taken care of the power rule here. Now we can go to our product and quotient rules. And again, we're going to be working backwards. We have 2 separate logarithms that are added. So if we want to condense these into a single logarithm, log base b of some stuff, then what I'm going to do is addition outside turns into multiplication inside. So we are going to multiply x to the 5th times y to the 6th inside a single logarithm. So we've now taken what we've started with and condensed it into a single log. And so that's when you know you're done, when you have one log. Okay, let's try number 2. First thing that we're going to do is the power rule. Do we have any numbers out front that need to go up into an exponent? We sure do. We've got a 2 right here, so we're going to toss it up into an exponent here. So this is going to turn into the ln of 3x plus 7 to the second power minus the ln of x. Okay, we've taken care of the power rule. There's no other numbers in front. Now we're going to do the product and quotient rules. So this subtraction here, what does that mean? Subtraction on the outside turns into division on the inside. So when we combine these into a single logarithm, then we are going to turn this into division. The thing with the positive logarithm, which is this 3x plus 7 squared, that's going to go on top. The thing with the negative logarithm, that x is going to go on the bottom. So this turns into division, top minus bottom. And we are condensed. We have a single logarithm. And don't bother expanding out the top. Don't FOIL that out. That is not worth it. We're just trying to figure out where everything goes. We're putting our toys away. You just got to figure out whether they go on the top shelf or the bottom shelf. Okay, so number 3. First thing that we're going to do here is the power rule. We're going to take each of these numbers out front, and we are going to toss them up into exponents. So we will have log base 2 of x to the 7th minus log base 2 of y to the 3rd plus log base 2 of z to the 1/2. All right, so we've done the power rule now. Now we just have to do the product and quotient rules. Now, especially because we've got some things that are positive, some things that are negative, I don't think it's worth it to reorganize everything. We're going to do the product and quotient rules backwards together. We're going to put our toys away. So we're going to make a single log here, log base 2 of a bunch of stuff. And because we have some things that are negative, I know there's going to be some division in here. And so I'm going to make my division bar. And then we just have to put our toys away. X to the 7th, is it going to go on the top shelf or the bottom shelf? Well, its logarithm is positive, so it's going to go on the top. X to the 7th goes on the top shelf. This y to the 3rd, is it going to go on the top shelf or the bottom shelf? Well, its logarithm is negative, so it goes on the bottom shelf. And then z to the 1/2, does it go on the top shelf or the bottom shelf? You're right, its log is positive, so it's going to go on the top shelf. And so now our toys are all put away. We've got a single logarithm. We are done. You can put a box around this and move on with your life. Or if you wanted to, z to the 1/2, you could write that as the square root of z if you wanted to. Alex will take both of these answers, so you can choose which one you like better, which one is easier for you to input. All right, last one here, number 4. 2 ln x minus 4 ln y plus 8 ln z minus 5 ln of w. All right, we want to condense this into a single logarithm. So what do we do first? Yep, we do the power rule. We're going to take each of these numbers and put them up into an exponent. Sorry that this is so messy. So this is the ln of x squared minus the ln of y to the 4th plus the ln of z to the 8th minus the ln of w to the 5th. So we've taken each of those coefficients and put them up into an exponent. We don't have anything left out front, so now we can make a single logarithm and put our toys away. Because I have some things that are positive and some things that are negative, I know I'm going to need a division bar and I'm going to need some shelves. So now let's put our toys away. X squared, does it go on the top shelf or the bottom shelf? Its log's positive, it's going on the top shelf. The y to the 4th, top shelf or bottom shelf? Yep, its log is negative. It goes on the bottom. Z to the eighth, top or bottom? Yep, it goes on the top because it has a positive logarithm. And W to the fifth, top shelf or bottom shelf? Absolutely, it goes on the bottom because its logarithm is negative. We've now condensed into a single logarithm and we are done. So I actually think condensing is easier than expanding because you just have to do the power rule and put your toys away. Alex might show you how to rearrange and factor out negatives. I honestly don't think it's worth it to kind of figure all of that out. Once we know that anything with a negative logarithm came from the bottom, anything with a positive logarithm came from the top, we can just do all of those product and quotient rules together and put our toys away. All right. Last thing that I wanted to do here are these last few examples at the bottom. It says use properties of logarithms to evaluate each expression without a calculator. All right, so we're trying to do all of this without a calculator. So number one, the ln of e to the fifth minus 2 times the ln of e to the sixth. Okay, well, we've got some subtraction of logs happening, and I have a number out front of this one. Let's first condense this into a single logarithm, and then we can see if we can simplify it at the end. So let's condense just like we did before. We got a number out front. We're going to do the power rule first and throw that up into an exponent. So this is the same as the ln of e to the fifth minus the ln of e to the sixth squared. All right, I've got powers, 2 powers. So let's simplify over here. This is the ln of e to the, if I have a power to a power, you multiply those. So this becomes e to the 6 times 2, which is 12th power. Now from here, we can either condense this into a single log, but you might notice that we can simplify each of these in its current form. I think most people's brains actually work better if we simplify from here rather than trying to condense all the way down. The ln of e to the fifth power. Well, this is really log base e of e to the fifth power, right? Because the ln is log base e. And I can do that again over here. And what this really means is this one over here says e to what power gives me e to the fifth power? And the answer is 5. So this whole thing reduces to 5. And we can do the same thing over here. This one means e to what power gives me e to the 12th power? And the answer there is 12, right? E to the 12th power equals e to the 12th power. So this is just 12. So this simplifies to 5 minus 12, and 5 minus 12 is negative 7. You can absolutely do that whole thing without a calculator. All right, let's go to number 2 here. Log base 14 of 7 plus log base 14 of 2. Well, I'm adding separate logs. If I add separate logs with the same base, what can I do? Well, I can combine these into a single logarithm, and addition on the outside becomes multiplication on the inside. So this is the same thing as log base 14 of 7 times 2. Well, 7 times 2 is 14. Log base 14 of 14. This is something we can simplify without a calculator, what this means is 14 to what power gives me 14? And the answer is, yep, 1. 14 to the first power is 14. So this is just 1. And the last one here, number 3. Log base 3 of 36 minus 2 log base 3 of 2. All right, let's condense this and then we can go from there. So we've got a number out front. Let's use the power rule and put it up top here. So this is log base 3 of 36 minus log base 3 of 2 to the second power. 2 to the second power is 4. So this is log base 3 of 36 minus log base 3 of 4. Okay, so now I can subtract. We've got subtraction of 2 separate logs. I can combine these into a single logarithm. This is log base 3 of, this is subtraction. Subtraction outside turns into division inside. So this is log base 3 of 36 divided by 4. 36 divided by 4 is 9. So this is log base 3 of 9. And again, we can evaluate this without a calculator. This log base 3 of 9 says 3 to what power gives me 9? And the answer is 2. So this whole thing is 2. So you'll use these properties of condensing to help you figure out how to evaluate things and get to something that you can evaluate without a calculator. I do just want to mention here, so here with 2 and 3, I combined all the way to a single log before I evaluated. And in number 1 here, I didn't combine into a single log before I evaluated. I evaluated here beforehand. You can really do either one if you can. If I had tried to evaluate here, log base 3 of 36 and log base 3 of 4, I wouldn't have really been able to simplify each of these at all. This one says 3 to what power is 36? And there's not really a power of 3 that gives you 36. 3 to the first power is 3. 3 to the second is 9. 3 to the third is 27, and 3 to the fourth is 54. So 36 isn't in there. It's not a nice power of 3. So I could not have simplified at that step like I did in number 1. Same thing here in number 2. If I had tried to simplify right here, I wouldn't have been able to do it because this says 14 to what power gives me 7. And there's not a nice power of 14 that gives me 7. But here in number 1 here, at this point, I could get nice numbers. Alternatively, you could have combined these in this step and you could have said, well, this is going to be the ln of e to the 5th divided by e to the 12th. You absolutely could have done that. And then you would have simplified inside to get e to the, when you divide exponentials with the same base, you subtract their exponents. So e to the 5th divided by e to the 12 is e to the negative 7th. So then you would have done the ln of e to the negative 7th, and you would simplify that to negative 7. You would get the same thing either way. I just did it this way because I think that if your brain sees that this is something that you can simplify, this is a much easier operation than this is for most people's brains. So that's why I kind of did it the way that the way that I did. If you can simplify it an earlier step, you can absolutely do that. But if you like to have a consistent process, then you can go all the way to a single logarithm before you do that simplification. Okay, I hope that's helpful. Um, Go forth. Homework 11 is due tomorrow, which is Wednesday, April 12th by midnight. Let me know if you have any questions, and I'll see you tomorrow in class. Have a lovely day.